Good afternoon, everybody. Am I audible?
Yes, sir.
Okay. Okay. So let us go with cues. And after you finish the exercise which I have given to you, then I will try to explain you how you can do that along with the code as a demo. But before that, without any waste of time, yesterday we have even discussed about this what we say the linked list stack operation. So you might have understood how you do the stack operation. I have given a hint, right? Using the top, you can insert the latest element. So it is in the big O of one complexity. And also you can go for deletion using traverser, but you should be deleting only the last element where the top is pointing to. So whenever you delete a node, then the top should be given to the previous node. I have even discussed with you about how you can write the code for that. Okay. Now after this, today we discuss about the queues. So in stacks, we have done the operations on arrays and also linked list. In queues also, we will do the same thing. First, we will discuss only the queue, and then we can go for discussion on the linked list implementation of the queue. So only queue in the sense because there are different queues like the priority queue, the double-ended queue. So sometimes we call DQ, and we only come to queues here, only queues. That it's the minimal functionality of how a queue works. That's only what we want to discuss now. Okay, right. So I will tell you the simple operations of how the queue works, and these both arrows indicate something like this. The blue indicates, I'm now pointing to blue, you see. The blue indicates front, the red indicates, the red arrow indicates rear. Okay, so I will keep them as R and F, front and rear. Something you can take R and F or front and back or something, whatever it might be. But these are default notations like your push and pop operations. Remember, when you are keeping something, inserting something in the queue, it is called enqueuing. Enqueue. If you are taking out something from the queue, that is called DQ. Okay, NQ and DQ. And finally, we can have a final display. So most of them works like a stack, but still a small change is that instead of top, we have two pointers now. One is front and the other one is rear or. Initially, if the queue is empty, both front and rear will be at -1 position. You can see they are pointing to -1 position. Okay. For the first time, when both are at -1, see clearly, when both these pointers are pointing to -1, and if you are trying to enqueue an element, if you are trying to enqueue an element into the queue, then remember the first step that you need to do is that increment both front and rear. Increment both front and rear. Again, I'm telling you, if your front and rear are pointing to -1, and if you want to enqueue it, you understand that this is the first element that you are enqueuing. So naturally, you should increment both front and rear to minus +1, so it will be 0. The reason is if you write some element like 2, so that means your queue is having only one element which is itself a front and which is itself a back or a rear. Imagine that you are buying a ticket for your cinema. you are standing at a queue to buy the ticket. So you are the first person and you are the only person in the queue, then you are also the last person, right? So that is the reason why we say both front and back or rear pointing to the same location if you have one element. So this time I am enqueuing one element here. So 2. Okay, I'm enqueuing 2. Now again you want to enqueue 5 this time. Enqueue 5. So what happens now? Front will be at 2 because the 2 is at front still. And only your rear increases. Okay, only your rear increases and it is pointing to 1 now. So this is where you put your 5 as an element because you are trying to enqueuing it. Okay, it's like inserting element. Again you want to enqueue 10 this time. I'm not talking about order of inserting. I'm talking about inserting some random numbers. And of course, they are coming as ascending, but it is not about order. Okay. Now I'm enqueuing 10. So the first thing that you need to do is increment your rear to the next position and put down the element that is new wherever the rear is pointing to. So I am pointing to 2. So I will keep 10 here. Okay. So after this, if I want to enqueue 11, so I will just increment rear and enqueue 11 there. So I am keeping 11 here. Okay, right. So stop this. Until now we got this. So Q is also working on an array data structure which is fixed in size now. We can put 6 elements at a time continuously. More than 6 is not at all possible because the queue is fixed in size now. Okay. So can now you tell me, anybody can open your mouth and tell me which, if I want to dequeue it, which element might be dequeued? Is it 11 or 2?
2, sir.
2. The reason is there is a policy of queue that is called first in, first out. And you can also say the last in, last out. Okay. Because when you are standing at a movie to buy the ticket, okay, these are all the people at the back side. So you will be given the ticket first. If this person is given the ticket first, you will quarrel with the person, right? So you will be given, you will be sent out. Next, he is the first person. You'll also be sent out. Next, he, she, or something, and go on, right? So this is how it happens. So just look into the difference between stack and queue. This is stack and this is queue. If you have stack here, the last element is the first element to be out. If you have a queue here, the first element will be the first to get out. See the difference. After in, you can get out this one, and after this one, the in can be from this side and out can be from this side. So that is the reason why I am inputting in this direction and increasing the rear. Now I am making this element out and hence I will decrease the front because this one is served and this is not usable. This is served and this is not usable. Okay. Now let us let us now come to DQ. So I call DQ function. When I call DQ function, remember that you have to increment your front, that is in the blue color. Okay, you have to increment your front. Now can anybody tell me how many elements are there in the queue? Is it 3 or 4?
3, sir.
3. The reason is already we have discarded 2 because 2 is served and your pointer moved to here. Now 5 will be your friend. You see, your 5 will be your friend. So whenever I call display, your I will start at range friend and ends at rare plus 1. Remember, it ends at rare plus 1. In stack, it starts at 0 and ends at top plus 1, right? Here, the display will start at this position, that means the front, and ends at rare plus 1 position because it is up to. So 5, 10, 11 will be only in your queue. And if I call the DQ again, it will be incremented. Now there will be 10 and 11 in your queue. And if I DQ it again, this will be incremented and both pointing to the same location, that is 3. So there will be one element 11 and 11. That's all, because both front and rear are only 11 here. And if you want to DQ it again, remember you should produce an error saying that you cannot DQ further anymore. So that means you can say you have DQ'd it, because the front should never bypass rear. Can you do that? Can you do the front to be bypassing the rear? You can never do it, right? So because, for example, you imagine a train, all the bogies are added one after the other, and sometimes there are trains where even every bogie acts like an engine, so you can also add it in the front. So you cannot bypass front in the rear because it will never happen in this world in the real time also. So now it will happen because if you write a program in such a way that the front will bypass rear, but it is not following the rules of law. So now what you have to do is, when front and rear at the same position, don't go for DQing it. So just leave it like that. It's almost deleted. You can write your own logic for that. And again, there are two elements that we can insert. That means if I want to enqueue some other thing like 100, I can again increase the rear and put that one. So I want to store 100. And then I can again enqueue by storing some, sorry, yeah, 200, 200, right? Now after this, I cannot enqueue anything because this is the last thing that I can do for enqueuing. I can do dequeuing up to this particular position. So I can dequeue it so that it increments, I can dequeue it and end. You cannot go further more. So if you want to put more enqueuing, you should produce an error overflow. If you are trying to keep more dequeuing, you can say it is underflow, or the queue is nil, or you can say the queue is full. For example, you see that now your friend is still here and you have finished all the elements to be inserted, and still you want to enqueue it. Nothing. It will come back and say the stack is full. Sorry, the queue is full. You cannot insert more. And you can also say that if you are trying to still delete something, some elements from this when both are pointing to the same last location, that's all, you leave it. What is the necessity for you to do? So maybe you can also say you can increment to other one, but it says the index out of range. You leave it like that and say simply the queue is dequeued completely, right? And after that, there is nothing to do. You can make them to -1 or something, and you can set the values of both to 6 and say we cannot go forward, right? If it is maximum. So for example, if I want to DQ this one also, what you can do is you can increment both to the next one and say it is the value 6. Okay, it is the value 6. That's all. And when they are pointing to 6, whenever you try to call these functions enqueue and dequeue, you need to check out. If both are pointing to value 6, that means we have deleted the entire queue and nothing to NQ and nothing to DQ and produce an error that this is not possible. Okay, this is a simple thing that you can do here. I hope you are understanding what I am doing. Because I have explained the whole list of working of memories in the stack, I am not going to deal with the working of memories. Because you understand the pointers are very important to deal with queues or stacks. So that is why I have directly jumped into this. Now you might ask me, sir, what is the real-time implementation? Yes, I will go for the real-time implementation. If you consider CPU, this is the processing unit, right? Maybe Intel or something, some processing unit will be there. You want to print, you have kept a print command, you are trying to execute a program, you are trying to open a browser, and these are the three things that you are doing. And remember, each one of them is called a process. This is called process 1, process 2, and process 3, right? And you should remember that operating system plays a major role in keeping up this. Whenever you say print my paper and immediately you executed something and open the browser, they will be executed one after the other if it is a single core. You might ask me, sir, they are parallelly doing everything. How are you saying this one? But remember, guys, nowadays your CPUs are multiple cores. Maybe you can say that they are divided into 4 core or 8 core, and each one acts with single one. So you can run P1 here, P2 here, and P3 here, and so on. But it is not possible in the earlier days. Even if you want to run in one core also, you need to have a queue. So how the queue works here? Now there will be something like a queue where all your process will be queued in. So you can see here, so P1, which is the first process that is there, will be queued in P2 and P3. Whenever the process is ready for executing, the queue works in the same way. So for every few clock ticks, the operating system will create a queue of process. And furthermore, if you are executing more programs, have you seen it says hanged up or the system might be busy? Sometimes it happens with your phone and your computer. It used to happen more frequently when I bought my computer for the first time in 2003 because they are not that much faster. Now, because we have multiple cores and RAM is very fast and everything is good now, not many people have seen that one. But this question, if I asked it in 2012, still in 2012 and 2011, when I'm working as a junior assistant professor, then people used to raise their hand, yeah, we faced this problem because still the computers are not in order at the time. And I think the 10 years passed by now. So most of your computers are very busy at doing multiple tasks and you don't never find a deadlock situation or a hangout situation. Very few rare conditions, that is. So when the processor is ready, then your operating system will move the front to this one. So we are working in a reverse way. Okay. Now the rear is here and the front is here. So P1 is served because P1 is sent for the CPU to execute. What do you mean by process? Process is a program. See, when you are running your program .py file, this also comes as a process for the CPU. So all your softwares are processes, right? Even printing is a program. It does something, execute some instructions in the CPU and perform your print operation. So every program is actually queued in a small queue data structure and each process is served. So after P1 is served, next P2's turn. So what it will do, it will increase the front here and P2 also will be served. And finally, after P3 is also served, then it destroys the entire queue here because every process is served in the CPU. And for the next waiting processes, it will create another queue of certain size. Or its queue might be dynamic. It is increasing the queue and so on. But what is the basic principle? The first process that comes into existence for execution should be the first process to be executed. That's the priority base. Did you understand? So all the process that comes for execution in the CPU, the first process that comes should be given priority. That's what the queue means. Okay. Now let's write the code now. If you understand how the queue works with front and rear mechanism, now you will help me in writing the code. Writing the code for enqueuing, dequeuing and display. Simple operations. And then after this, you will practice in the next session. And after that, I will give some puzzles for you also regarding this. Right. Let me rub these things so that we will start from the first while writing the code like how we have written for the stack. Right. So both start at -1. So anyway, as you have understood, there will be enqueuing, dequeuing and display. So let me write all of them. Enqueue always needs an element to be enqueued. The next one is dequeue. So dequeue needs nothing. It's just a normal function. Whenever you call dequeue, you should work it out. And the final thing is display. Let me rub this one also so I will have some space for it. So instead of this, if I can create boxes for these three things, that will be fine for me to write down something like that. Okay, I will create the boxes for them. Now I'll create boxes for them. Okay, this is for enqueuing. Okay, and the next one is for dequeuing. Oh, this is actually there. Okay, I will keep it like this. Okay, I will just rub it off this one also. That's will be fine. So I want a special place for that. So you already know this, right? The blue color is front and the red color is rear. Like this, we can go. Let me keep these things like this. So it will be fine that you can write good programs like this. Copy, paste. So for dequeuing, I will give some other color. Okay. For display, some other color. Okay, right. So three colors are there. I will write a small name for enqueue of element, dequeue, and display. Okay, I will take the black color so it will be fine for all. Okay, now I want to insert an enqueue element. So enqueue 5. So can you tell me what to write as a code? Anybody? What will you first check? What is the condition that I told that you will first check? Am I audible? Hello?
Sir, you're audible, sir.
Hmm. Now what is the condition that you will first check, as I told you, where front and rear are at this
At
moment?
-1, sir.
Yes. So the first condition that you will check is if f is equal to -1 and r is equal to -1, what you will do? The first step, what you will do?
We should move both of them to 0th position, sir.
Yes. So +1. So f is equal to f +1, r is equal to r +1. That's all. So both will go to 0th position. Now, as I told you, whenever you are trying to NQ something, the NQ'd element should be at a position where the rear is. So what is the next step that you want to do?
Sir, we will move front.
No, front and rear both are moved. Actually, now you have to put the element 5, which you want to NQ into the queue. What is the next step with this condition? If you say this one has q itself, for example, this is q, okay? Now tell me, how do you do that, pointing to this array?
Sir, Q of F is equal to element.
No, I said that it should be, whenever you are NQing, it should be at the rear position. It's not front position. So what do you do now? Just change a little bit. Instead of f, you,
Q of R equal to
yes,
-1.
q of r. So wherever the r position is, that means it is at 0, is equal to the element that you received. So this is the one. If both f and so let us come to the next one also. So let us keep this 5 here. So according to these steps, it will work. So we have incremented f, we have incremented r, and q of r is equal to the element 5. Finished. Now I want to NQ 100. Now, coming to the first condition in the NQ, both f and r should be -1, but they are not -1. So what do you do now? I need to write else statement. So tell me what will be in the else statement.
Increment only R.
Sir, Q of R is equals to element, and we should increment the R value by 1, sir.
No. First increment r value, then it will go to the next one. So let us write this one. R is equal to r plus 1. So what happens? It will now go to next position. And in this position, you have to keep 100. So for that, what you
Q
need
of
to
R
do?
is equals to element.
Correct. So Q of R is equal to the element that you received, that is 100. So immediately write down. That's all. Now again, I am NQing 99. So this time also f is not equal to -1, r is not equal to -1. So it comes to the else position. So r is equal to r plus 1. Okay, do it. R is equal to r plus 1. And q of r is equal to element. So wherever r is pointing to, we write the element there itself. So it is something like 99. Fine. And again, I am NQing 1. Again, it comes to else anyway. Again, we should do that r is equal to r plus 1 and q of r is equal to the element. So now we have to put 1 here. Okay. So, right. Okay. Until now, okay. Now I will call dq. So now let's write what is dq function. Can anybody tell me how you will write dq?
F equal to F plus 1.
I could not hear you. Can you speak out loud a little bit?
Sir, we should write the while loop, and it will loop until to raise, sir.
No. I only called one time dq, like your pop. So what do you do
Sir,
in
f is equal to f
F
plus
equal to
1.
F plus 1.
yes, that's all. So f is equal to f plus 1. But I have one condition for you. So by this time, okay, I will write again dq. Again f is equal to f plus 1. Okay, so it will come here. Again I will write dq. So again
We
f
have
is
to use a
equal to,
condition, sir.
yes, what is the condition that should I write now? So
If
because if both front and are pointing here, right? Can I do dq again?
no, sir, it will.
Yeah. So what should I write the condition now? What condition should I write now?
If f is equal to r,
If f is equal to r, that means both equal to, that means comparison. Now what you will do? So you just increment both of them. If both are equal, you just increment both of them. That's all.
f
So
is
how do you
equal to
do
f
that?
plus 1 and r is equal to r plus 1.
Yes, f is equal to f plus 1 and r is equal to r plus 1. That's all. This is how you do it, right? And you see clearly that whenever this happens, now you want to NQ it. Something you NQ again, NQ 200. And where it will go, whether it will do it as F or if or else in NQ.
It will go to else, sir.
Else. According to else, what has happened? R is equal to R plus 1. See, this happens now. What should we do? We are now leaving the element here. What should we do now? Should we write any other condition for NQ also?
Sir, we have to use an elif condition.
Yes, else if condition. What you will do now?
If f is not equal to -1 and r not equal to -1,
Can I suggest you something like, can you write R here itself? That R. Again, both will be there. Yeah, yes, correct. You are correct. So I will not expand further. Now you tell me what you should do.
if f is not equal to -1 and r is not equal to -1,
Hmm. So if possible, I will get it down. So I will
yes,
rub
sir.
it here and rub it here. If nothing is possible, then it will be possible. Yeah, you can say that L if both are equal. Okay, if both are equal, then we will do something. So F is double equal to R. If both are
Yes,
equal,
sir.
then you will do something like Q of R. Q of R is equal to element, right? And we will write the last condition anyway, because else you can simply say R is equal to R plus 1 and Q of R is equal to element. See all the conditions. If F is -1 and R is -1, you should increment both and put wherever the R pointing to. And if F and R are both equal to, that means already we have dequeued the entire Q. So directly put the element there itself. So Q of R is equal to element. And if these both conditions are not satisfied, that means it is a normal condition. So simply increment your rear and Q of R is equal to element. So we have seen all the conditions by now. And now we have to write something in the DQ. For example, if both F and R are not equal, what should I do in the else part? Oh, okay. Now, for example, I will put the condition like this. And we have filled, for example, we think that we have filled everything, 201. And now I want to DQ it.
Sir,
Can,
f is equal to f plus 1.
yes, that's all. F is equal to F plus 1. So in the same manner, all of you please think about how to produce the errors also. For example, if the entire queue is deleted and you still want to DQ it, how do you produce an error? Like I told you, right? Use the help of 6. That means another one which is out of bound. Like that, you can think about the errors. So now you have only two elements, 200 and 201. So we have written both NQ and DQ programs now. So in DQ, we have two conditions. If F double equal to R, that means if F and R are equal, then you just increment it both because you are calling DQ. And else if it is only F is equal to F plus 1, if nothing is satisfying this condition. Okay. So whenever you call DQ, because at this condition you see that both are not same equal. So you can simply say F is equal to F plus 1 like this, right? Now tell me the program for display. It's very easy. Tell me first.
Print Q.
Not print Q, because how do you print Q? Print Q means it will print the whole thing like no, 599, 1, 200.
Yes, sir.
Yes, how do you do that? From what to what the elements will be considered as part of Q?
Index 4
to
and
rear,
5.
sir. Front
It
to
is
rear.
from front to
Front to rear.
So you can say for I in range F to R plus 1. Okay. Now print Q of I. That's all. So all the elements from front to rear plus 1 will be printed. So these are the three important functions for your Qs: NQ, DQ, and display. So I hope you understand how you write the code. Just by drawing something on paper, you can simply write the code like this. And now I will ask you, what is the disadvantage that you found in Qs? Clear disadvantage.
Memory, sir.
Memory. So where you find that memory loss is there?
Sir, we are not deleting the elements, sir.
We are not deleting the elements. Of course, that will be there in the stack also, but we replace it. But you know this one that these are not even getting replaced, and you cannot put new elements into this. For example, you take a stack. You take a stack like this. Whenever you pop out something, you can again just fill it. Again, you can pop it, fill it, pop it, something. Your entire memory will be in use every time. But you see, once you DQ it, you cannot go back. That is wrong. And this is the reason, once the queue is filled, you cannot put back elements. So stack can be infinite times. You can pop it and push it. Push some elements and pop the elements. But in queue, it is fixed. Once you are unqueuing it, this entire memory will be wasted. Because once you are dequeuing it, this entire memory will be wasted. It is not usable for any other program or for you also, because you are still catching hold of this. You are just saying that your elements are not important for you, but still they are part of your array. So this is the entire disadvantage of the queue. So can anybody tell me any solution for this? How do you reuse these locations so that it will be fine, that there will be no waste of memory like this? Did you understand my question? Can anybody say yes or no? Hello?
Sir, yes, sir, understood.
So is there any solution for this? How can we use from 0 to 3 again? You cannot go back in queues. Once you dequeue it, the front will be incremented and the earlier elements from 0 to 3 are wasted. You cannot use that memory location also, like your stacks. So in stack, how many times you pop it, those many times you can push some elements. You can use the same memory again and again. But in queues, once the memory is lost, you can never go back again. That's not the rule of the queue. You can go only in the forward direction of adding the elements. Because already it's a fixed queue, you cannot add more and more. So we are leaving like that. So from 0 to 3, they are just standard there. How do you get back to 0 again? 1, 2, 3, like that? Any solution from your side? Again, I'm telling
Sir,
you.
should we replace the, I mean, existing q values in the 0th index and the first index?
Yeah, what I mean to say is, let me reiterate it again. So your queue is like this, right? Okay, it's a fixed size. So that means you can only insert the elements in these positions. That's all. When you have both rear and front at this position, you want to add another element. It will say the entire queue is full. Then you might be wondering, what about these memories? Because these are discarded, why can't I add a new value and replace some other previous values that are there by replacing it? But it is not possible because Q always goes in this direction. You cannot increment this one to this one to this, and go on. That's not possible. You always can only go in one direction, that is only to the forward direction. And the end of this forward direction, you have only one element with you and no elements to be added because it's a fixed size queue. Then how do you do this? How do you solve the problem? So that I want to use, I should be back here and use all these elements also up to this one. Did you understand? Again, clearly I have explained the question. These are wasted. I want to use them back. In normal queue, these are always wasted and it's a complete bluff in the memory. This is the disadvantage of a normal queue. How do you solve this one?
Sir, I
If you
understood
want,
the question,
yeah,
but I cannot think of the solution, sir.
yeah. If, for example, if your friend is here and rear is here, if you want to enter an element at position, what do you do? Can you just tell me?
Sir, we increase the, I mean, we append it to the rare, no, sir.
We increase the rear and tell that the Q of rear is equal to the new element.
Yes,
Okay,
sir.
fine. And still you want to enqueue it, and the front is here. So our thing is that these memory I want to use it. So what is the solution that you do?
Sir, front is equal to front minus 1.
That's what I said. The front cannot go back. The front can
Oh, okay,
only
sir.
go
Yes,
forward.
sir.
The rear can also go forward. But how do you get back to this? So if I want to enqueue and the rear is already at the last position, you cannot enqueue further. But I have three elements which are ready to be replaced, and I'm wasting these three memory, because the front is here. So
So
you
can
have
we restart the variable, sir?
yes. Can tell me what do you want
Can
to
we
do?
restart it, sir?
Yes, you can restart it. So that means from this you can go this one. Why can't you go like that?
Yes, like it's there in the 51, no, sir. So directly we can go to, like we will make the variable as 0 and then again we can start it, no, sir.
Yes, that's correct. That is
Sir,
called.
I was about to say that.
Yeah, that's good. That's good. So if you all have those ideas, then your brains are working very fast. That's correct. So this is called circular queue. This is called circular queue. So what you imagine a circular queue like this. So a circular queue is imagined like this. So for example, 1, 2. So this is 0, 1, 2, 3, 4. So after 4, if the rear is at 4, now your rear might be at 4. Okay. This is the place where rear is there. So what you do next, if you want to enqueue and your front is at this position. So I'm writing this as front. So these three are blocked out, right? These are blocked out actually. So this can be replaced now because your queue is from 2 to 4. Now to enqueue something, these two places which are in black color are usable. So what you do, you simply increment your rear, take out that blocking away, and put your rear here and replace with a new value. right? What you are enqueuing it. So now your queue will be 2, 3, 4, and 0, like that. This is called the concept of circular queue. So a simple condition will make your queue as a circular queue. Did you understand? It's like I think in your childhood you might have bent your refill and connected it to its rear. Have you done this or not? So we can bend our refill with a needle point and we can connect it to our rear so that it forms a circular one. So we used to play like that for some games or something. So where is this? Okay. So in the same way, you just after rear comes to the last position, the next enqueuing, if it sees that the 0 is empty, then connect it to 0. So your condition should be like this. If rear is last, find 0 is available or not. Then you can say rear is equal to 0 and Q of R is equal to the new element. That's all. This is a circular queue, concept of circular queue. Just try it out, and in the afternoon, if in the next class, we can discuss if there is any doubt in this. Okay?
Sir,
Yes, tell me.
sir, can you please upload the yesterday's class
Yes,
video?
yes, I will upload all of them because I do not find time for some time, so I will upload it by today. Okay?
Sir, okay, sir, thank you.
So bye bye for